In the last video, we used the very simple Sandbox Bypass from version 1.08 and checked why it doesn't work anymore for 1.47. After that, we started to look at the Sandbox Bypass from Gareth Heyes for this new version. In this video, we will continue where we left off last time and debug the AngularJS code, evaluating the evil expression that will lead to an alert. So, as a quick reminder, the Sandbox Bypass looks like this. It has two parts. The first part attempts to override the char_add function with another function, which hopefully screws up Angular internally. And the second part is $eval, which is the Angular eval to evaluate an expression. So this is basically a new expression inside of the other expression. Also remember that a lot of stuff has changed internally from the old version. The concept is the same. AngularJS parses an expression, evaluates it, and somehow executes it. Just how it's done has changed. We will see what it does by stepping through the code. Okay, let's start for real. Here we are at the first breakpoint that we hit after we load the page. I placed this breakpoint into a function called lex. This is the lexer. Wikipedia tells us that lexical analysis is the process of converting a sequence of characters into a sequence of tokens. The lexical analysis is basically the first step in a compiler. So if you're a computer science student and always wondered why the heck you ever need to know compiler construction, here is a real life example. Also, if you look at the call stack, you can see that the lexer is called from somewhere with the name AST compiler, which stands for Abstract Syntax Tree Compiler. It sounds weird, but that is literally what it is. AngularJS implements a compiler that takes an AngularJS expression, which looks like JavaScript, and compiles it to real JavaScript. There's a damn compiler inside of AngularJS. A compiler that compiles something like JavaScript to JavaScript. Anyhow, still freaks me out. Back to the lexer. So, this function has one parameter called text, and text contains the current AngularJS expression. According to Wikipedia, this lex function should parse a string and extract tokens from it. And after our breakpoint, we can see a while loop that does exactly that. This while loop iterates over the full length of the text, and in each iteration, it will use text.char_add to get the next character of the string. So the first character would be the single quote from the string, A. When we step one step further, we get to an if that checks if the character is a single or double quote, which is obviously the case. So we will follow this and call the helper function readString, because this single quote is an indication that a string starts. And this whole while loop is full of ifs and helper functions like that. But in the end, we will get an array of tokens. So let's continue until this next breakpoint. Now we should have all tokens extracted from the expressions. This tokens is now an array of objects. The first object or token is the string A. Because it's a fixed string, this is also considered a constant. The next token is the dot between the string and the constructor. And the third token is the constructor, which is considered an identifier. All variable names and function names, etc. are identifiers. Also, for example, the eighth token is the equal, which is an operator. And before that, we have the char_add function name, which is also an identifier. Now, when I press continue until we hit the next breakpoint, a lot of stuff will happen. And we all skip that. Basically, this lexical analysis to extract the tokens was the start of compilation, and now we will have a look at the result of the compilation. So we skip the whole complicated compiling part. So, continue. And now we are here, at the end of AST compile. Just before our breakpoint, we have here this variable called fnString, stands for function string. And I printed that string to the console log down here. And this is the compiled JavaScript code. That is the result of compiling our AngularJS expression to JavaScript. This looks a bit awful to read, so let's copy it over into JavaScript beautifier to indent it and properly and have a look at it. Sweet. That looks more readable. It might look crazy and complicated first, but it's actually pretty simple. So first of all, this code starts like our expression with a string A and stores it in the variable 4. Then it attempts to get the constructor from variable 4. so the constructor of the string. After that, AngularJS added a function ensureSafeObject to check if the constructor of variable 4 is safe. And because that's just a string constructor, it's considered safe. Remember that this function was responsible for the exception when we tried to access the function constructor with the old bypass. After that, the constructors moved into variable 3 and checked if it has the property prototype. If that's the case, the reference to prototype is saved in variable 1. And as a last step, we check if the string prototype stored in variable 1 has a chart property. Now, we are done with the left side of the assignment. Up next is the right side. Here we start also with the string b. It's moved into variable 5 and follows it up with referencing concat of it, moving it into variable 0. Then AngularJS checks if chart of variable 1 is a safe object, but that's obviously just a normal chart function and that's considered safe. Afterwards, variable 1 itself is checked, because we are about to assign something to the string prototype in variable 1, and AngularJS wants to be sure it's safe to assign something to that object. Oh man, if AngularJS would just know what is about to happen. Now the crucial part. We assign the concat function in variable 0 to the chart function of the string prototype in variable 1. Now the first part of the exploit is done. At this point, chart should have laid an alien egg inside of Angular's body, which is about to break out of Angular's chest. The following few lines are then the second part of the exploit, which is fairly short. It basically gets $eval now from the scope object, does some checks on those variables, including the string parameter we pass to $eval, but it's just a string, so all is safe. And eval is called, which initiates another parsing, compilation, and execution of this string. Now that we understand the compiled code, let's see what happens with that. After our old breakpoint, fn string is used in call to the good old function constructor, which will create an actual function that can then later be called. At the end, it will return this function fn. I'm about to hit continue again, so we will jump to our next breakpoint. Go, boom, okay, ensureSafeObject. In the call stack, we can see that we are coming from fn, and fn is this compiled function. You can pre-print this code by clicking on the curly braces in the bottom left of the source window. Yep, this looks familiar. Just what we looked at before. Here's our string a, and getting the constructor of it, etc. When I now continue, we are again in ensureSafeObject, this time further down in the code. Actually right before we assign and override chart. Just one more check before the ensureSafe assign context. Okay, let's continue a bit more until we are back inside of the Lexer. But why are we here again? Well, as you can see, in the call stack we are coming from fn. And fn called $eval. And $eval is just now triggering evaluation and execution of this new expression string. And as expected, text is simply what we pass to $eval. But let's step further. We are again heading into the while loop that is supposed to extract single tokens from this character sequence. The index starts again at 0. So now AngularJS tries to get the first character from the string with chart. But chart is not chart anymore. The alien hatches and feeds on Angular's intestines. Char at 0 appends now 0 to the string, instead of returning a single character. So ch is super long and thus not the start of a string. It's also obviously not a number, but the validation function is ident thinks that this is now an identifier. Remember that usually variables and function names etc. are identifiers. That means that usually identifiers do not contain special characters such as equal or curly braces, whatever we have in this string. And if we continue now to the end of the loop and look at the tokens, we can see that there is only one token, and it's an identifier with our whole string. That's just wrong. An identifier should not have those weird characters inside. If we continue now, we hit the next breakpoint at the end of compilation, and we can have a look at the resulting JavaScript code. Let's again copy it over to JS Beautifier to see what happened. Can you already see here the part 2 of our exploit embedded in the JavaScript code? You can also see that it's s.exploit blah blah blah. Remember that all expressions are evaluated against the scope object? Well, because AngularJS thought we had an identifier in our expression, it placed that identifier in the compiled code by checking if the scope object has such a property. In this case, this totally blows up because the identifier had non-valid identifier characters. When you ident it properly, it becomes more clear. You can see now the start of our expression with the exploit equals 1 and then the 3 closing curly braces. Then the breakpoint and then the alert 1. So when we continue now, we should hit that breakpoint. Boom, indeed! We are inside of the compiled code at the breakpoint. Pretty printed again, and let's enjoy this beauty for a second. Then hit continue and we will execute alert. Awesome! And this is how the AngularJS Sandbox Bypass for version 1.47 works. We override the chart function that is shared for all strings, which will break how AngularJS parses expressions, allowing us to inject bad characters as an identifier in the compiled code, which we can abuse to break out and write arbitrary JavaScript code.